Okay, let's get into this. I mean, if you're working in professional video, you already know the single biggest headache out there.
Oh, absolutely. Distance.
Distance, exactly. So today we're doing a deep dive on high-definition video transmission, specifically SDI,
Right.
and how you get around that really fundamental physical limit.
Right.
And our source material for this is a particular piece of hardware, a converter kit from a company called Thor Broadcast.
A really compact one, actually.
Yeah, it's tiny. And it makes this huge claim that it basically shatters those old cabling limits. So we're going to break down how it works and, what that actually means for you.
And you really have to start with that physical constraint,
Right.
the cable itself.
The old coaxial cable.
Right. Your standard electrical coax with the BNC connectors.
Mm.
You're pushing a very high-speed electrical signal down a copper wire, and eventually it just runs out of steam.
It hits a wall.
It hits a hard wall.
Yeah.
And that wall is at about 100 meters.
Wow, that's it. A little less than a football field.
Yep. It's just a basic problem of physics and electricity.
Okay, so if electricity is the problem, the solution here seems to be, well, don't use electricity.
Exactly. You change the medium.
So these little converters we're looking at, the F-micro-SDI kit,
Yeah.
they take that signal and they turn it into light?
They use a tiny laser to convert the electrical signal into a pulse of light, and they blast it down a fiber optic cable.
And that 100-meter wall just vanishes.
It's not just gone, it's completely obliterated. I mean, this source material shows you go from 100 meters to 20 kilometers on standard single-mode fiber.
20 kilometers, that's a completely different scale.
And that's just the standard model. Some of their other SDI units can push that out beyond 80 miles.
80 miles. We're not talking about cabling a stadium anymore. That's like connecting cities.
It's the difference between running a cable across a studio and running one across a small state. It's a total paradigm shift.
But wait a minute. When you push a signal that far, my immediate concern is something's got to give, right?
What about quality? Is it still compatible with professional gear? That's the crucial question. And the answer has to be yes, or it's useless. And what's really important for you to know here is that this little rugged box, it isn't just a dumb converter. It maintains full professional compliance.
So it speaks the language of broadcast?
It speaks the universal language. It supports all the major SMP2E standards, 424M, 292M, 259M. So you can plug it into basically any pro camera, switcher, or monitor on the planet, and it will just work.
Okay, that's reassuring. But what about reliability under stress? I mean, live broadcast can have some really messy signals.
Yeah, and that's where this bit of technical jargon in the sources comes in. It supports full, error-free pathological pattern operation.
Which in plain English means what?
It just means it's guaranteed to handle the absolute worst-case, most stressful, ugliest data stream you can possibly throw at it.
Without dropping a single frame?
Without dropping a frame or introducing any errors. It's designed to be bulletproof. Plus, it has link alarm indicators, so you get that visual confirmation that your signal is solid.
All right, let's talk about where you'd actually use this. Beyond the obvious, like a huge live event, what's the hidden value here?
For me, the real aha moment in the material was about simplifying permanent installations. Think about high-end security systems or remote broadcast cameras.
Okay.
Well, this platform, the FM1SDI, it includes a return path serial channel, an RS-485 channel.
And that's for control data?
Exactly. For your pan, tilt, and zoom equipment.
Okay.
Your PTZ controls.
Ah, okay, I see where this is going. Normally, that's a whole separate cable run.
You got it. You'd need a big, heavy coax for the video, and then a completely separate cable just for the camera controls.
But with this,
that PTZ control data just hitches a ride on the exact same single strand of fiber as the main video feed.
so you've just cut your cabling complexity and cost in half.
Instantly. It's a massive deal for anyone doing surveillance or remote sports setups. And of course, it still carries all the embedded audio channels and other data you need, and it runs in pretty extreme temperatures.
So, to sum this all up then, this deep dive really shows a genuinely disruptive leap.
It absolutely is.
We've gone from a hard physical limit of less than a football field on copper to sending a perfect error-free signal for, well, over 80 miles.
All just by swapping the medium from electricity to light.
From copper to glass fiber.
Which leaves you with a really interesting final question to think about.
Go on.
If we can solve such an intense and long-standing bottleneck in pro video just by changing the physical carrier, what other common tech limitations that you deal with every day, maybe the slow data transfer inside your PC, or even the cable running to your modem, could be instantly solved just like that if we simply change the wire?